Okay, in lesson 10, we're multiplying decimal fractions with tenths by multi-digit whole numbers using place value understand to record partial products. Question 1 here told us to estimate the products, solve using the area model and standard algorithm. Remember to express your products in standard form. Okay, now if you look at this area model, you can see that they took the 53 and times 1 and 2/10, and they split it out between 1 and 2/10, and on the side they did 50 and 3. So when they multiplied it out, you can see this is 1 times 50 was 50, 50 times 0.2. Well, if I do 50 times 2/10, that's going to be 100 tenths. 100 tenths would equal 10. Over here, 3 times 1 is 3. And 3 times 2/10, 3 times 2/10 is 6/10, so it's written as 6/10. So when you add them up, you got 50 and 10 is 60, and 3 plus 6/10 is 3 and 6/10. Adding them up, we get 63 and 6/10. Now, when we're multiplying it out, they have here, it says 12/10 times 53. So I'm going to put the 12 over here so I can do my standard algorithm. That's 12/10. That's actually 12/10 times 53 ones. So now we can do our standard out. 3 times 2 is 6. 3 times 1 is 3. We're doing 50, so now I'm going to put a 0, and 5 times 2 is 10. 5 times 1 is 5, and 1 is 6. Add them up, we have 6, 3, 6. And we know that this is tenths. So this is 636 tenths. So in order for this to be 636 tenths, I would end up having to be 63 and 6/10. Now it says estimate. Well, when they're estimating, we have 53 times 1 and 2/10. 53 is closer to 50. 1 and 2/10 is closer to 1, so we know our answer should be close to 50. And you can see our answer was 63 and 6/10, so it's reasonable. Now question 2, we're going to have to draw our error model ourselves. So I'm going to go ahead and do a quick area model. And I'm going to put my decimal on top, and I can see I have 2 and 1/10. And vertically, I'm going to do 80 and 2. Now when we multiply it out, I can see I'm going to have, this is 2 times 2, so that's going to give me 4. This is 2 times 1/10. So this 2 times 1/10 would be 2/10. 2/10 is written as 0.2. Here we have 80 times 2. We have 8 times 2 is 16, add our 0. And the last one is 80 times 1/10. So that'd be 80 tenths. So 80 tenths would equal 8. When I add them up, I add 4.2 and 168 with 0/10. So we have 2/10, 12, we have 172.20. Now let's do a quick estimate here. We have 2 and 1/10, so 2 and 1/10 is closer to 2. 82 is closer to 80, so our answer should be approximately 160. And we ended up with 172.2. Now let's do the standard algorithm. 21/10 times 82. 2 times 1 is 2. 2 times 2 is 4. Put our 0, because now we're going to 8 instead of 80. 8 times 1 is 8. 8 times 2 is 16. We add them up. That's 2, 12, 7, and 1. Now, this is tenths, so we know it's tenths times ones, which will give us tenths. Now, we know our answer has to be approximately 160, so reasonable says we have to be 172.2. And also, if we say 1,722 tenths, then this has to be in the tenths place. Question 2, estimate, then use standard algorithm. So we're not having to do an area model this time. So 4 and 2/10 is closer to 4. 34 would be closer to 3. So when we multiply these, we have 0. 4 times 3 is 12. So we have 120. So our answer should be close to 120. Now we have 42/10 times 34. 4 times 2 is 8. 4 times 4 is 16. Place a placeholder. 3 times 2 is 6. 3 times 4 is 12. And we have 1,428 tenths. That means the 8 would be in the tenths place, so 142.8. And that is real close to our estimate of 120. Second one, here we have 65, which is 5 and above, so we're going to go to 70. 5.8, we know that's closer to 6 than it is to 5. So we can see this is going to be 0. 7 times 6 is 42. So it should be close to 420. Now we have 58 tenths times 65. 5 times 8 is 40. 5 times 5 is 25, and 4 is 29. 60 times 58, so we're going to put a 0 down, so 6 times 8 is 48. Carry 4. 6 times 5 is 30, and 4 is 34. Now we have 0, 17, 7, 3. But it's 3,770 tenths. So the 0 is going to be in the tenths place, so it means we have 377. Okay, doing our estimate first, 3.3 would be closer to 3, 16 is closer to 20, so we can see this should be approximately 60. So we have 33 tenths times 16 ones. 6 times 3 is 18, 6 times 18, 1 is 19. Put our placeholder, 1 times 3 is 3, 1 times 3 is 3. So we have 528 tenths. We know it has to be close to 60, so our answer has to be 52 and 8 tenths, because the 8 would have to go in the tenths place. On D, we have 15 and 6 tenths, which is closer to 16, and 17 is closer to 20. Excuse me, that's 16. 15 and 6 tenths, that's going to be closer to 20. Remember, we'll go to the closest digit. So now we have 20 times 20. We have 2 placeholders, and 2 times 2 is 4. So we know our answer should be close to 400. Now we have 15 and 6 tenths, so it'll be 156 tenths times 17. 7 times 6 is 42. 7 times 5 is 35, and 4 is 39. 7 times 1 is 7, and 3 is 10. It's our first partial product. Now we're 10 times 156, so put our placeholder. 1 times 6 is 6, 1 times 5 is 5, 1 times 1 is 1. Add up our 2 partial products, and 9 and 6 is 15, 6, and we have 3,652 tenths. So we know the 2 is in the tenths place, so we put 365.2. And we can tell by our estimate that that is the proper placement of the decimal. And our estimate says that it is a reasonable answer. Question E, 73 is closer to 70. 2.4 is going to be closer to 2. And so we have, answer should be approximately 140. So we have 73 times 24 tenths. 4 times 3 is 12. 4 times 7 is 28, and 1 is 29. We have 20 times 73, so we're going to take the 10 out. And now we have 2 times 3 is 6. 2 times 7 is 14. And we have 1,752 tenths, which means that 2 is in the tenths place, so it would be 175.2. And our estimate would also tell us that that's where we need to put our decimal place. Question F, last one. 193 and 5/10, so 193 is closer to 200. 57 is going to be closest to 60. We can see we have 3 placeholders and 12, so it should be close to 12,000. Now we're taking 193. It's actually 1,935 tenths. And we're going to multiply that by 57. 7 times 5 is 35. 7 times 3 is 21, and 3 is 24. 7 times 9 is 63, and 2 is 65. 7 times 1 is 7, plus 6 is 13. Put our placeholder, because it's 50 times 1,935, so we're going to put the 10 down here. Now it's 5 times 5 is 25. Carrier 2. 5 times 3 is 15, and 2 is 17. Carrier 1. 5 times 9 is 45, and 1 is 46. Carrier 4. 5 times 1 is 5, and 4 is 9. Add up our two partial products. We have 5, 9, 12, 10, and 11. So we actually have 110,295 tenths. Now we can see our answer was close to 12,000. Okay, so we can see that we would actually place our decimal plate right before the 5. And you also can see is that last digit would be in the tenths place, which it is. So it's 11,029 and 5/10, which our estimate is really close. Question 3. Mr. Jansen is building an ice rink in his backyard that will measure 8.4 meters by 22 meters. What is the area of the rink? Well, we know area equals length times width. So if I have a rink and it says it's 22 meters by 8.4 meters, and what is the area? So I can see that the length area equals the length, which is 22, times the width, which is 8.4. So now I know I have 84 tenths times 22. 2 times 4 is 8. 2 times 8 is 16. Put our placeholder. 2 times 4 would be 8. 2 times 8 is 16. That would be 8, 14, 8, 1,848 tenths. So we know that in order for it to be tenths, we'd have to put the place value there, so it would be 184.8. Now, if we did an estimate on this, we would go 22 is closer to 20 times 8.4 would be closer to 8, which equals 160. And that would be meters squared. So the same thing here, this is going to be meters squared because it is an area. Question 4. Rachel runs 3.2 miles each weekday and 1.5 miles each day of the weekend. How many miles will she run in 6 weeks? Okay, so let's take a look at 1 week. Let's draw an area model. Okay, now it says she runs 3.2 miles each weekday. So I'm going to take this and I'm going to say this is weekday. And I know this is going to be 3.2 miles times 5 because there's 5 weekdays. Now this is weekend. And I know the weekend is 1.5 miles times 2 because it's Saturday and Sunday. The top of the area model is going to be total miles for 1 week. So if we write an algebraic expression for it, we can see we're going to have 3.2 times 5 plus 1.5 times 2. And that's going to give us how much for 1 week. So let's do some estimation here. First off, we know 3.2 is closer to 3 times 5, so that should be approximately 15. So if we go 32 tenths times 5. 5 times 2 is 10, carry 1. 5 times 3 is 15, 1 is 16. And that's 16 tenths, so that'd be equal to 16. So we know this is equal to 16, which is good as far as our estimate goes. On the other one, it says 1.5 tenths. That's going to be closer to 2 times 2 equals 4. So we know this should be approximately 4. So we have 15 tenths times 2. 2 times 5 is 10. 2 times 1 is 2. 1 is 3. So that's 30 tenths. So we know 30 tenths would be written as 3.0. So it'd be 3. So we add these together, we can see our answer is 9. So it would be 9 miles a week for solving this. Now, if we come back to the problem, it says how many does she run in 6 weeks? Okay, so we have 19 miles a week times 6 weeks. 9 times 6 is 54. 6 times 1 is 6, and 5 is 11. So she runs 114 miles in 6 weeks, excuse me.